Hello and welcome to the first part of our new GB Labs webinar series. Thank you very much for joining us today, and I'm going to start the presentation in a couple of minutes just to allow a couple more people to join the session. Whilst we're waiting, I just wanted to point out that in your GoToWebinar control panel there is a questions section where you can pose questions as we go along, and at the end we'll have a Q&A and go through some of those together. So I think we'll probably make a start, and I'll start by introducing myself. My name is Ben Pierce, and I'll be introducing you to Cloak DR today, which is actually not a brand new product. It's been on the market now for about 5 years. We've got quite a lot of installations out there, and I think it's one of the coolest technologies that we offer. It's one that I've seen grow from just an idea to a very impressive reality. So if we move to the next slide, we'll just have a quick look at the kind of things that we'll be going through today. So I'm going to go through a number of topics in this webinar and discuss how Cloak DR fits into modern workflows. But first of all, we will look at the reasons why you would want this kind of technology. So obviously these days we are in very much the 4K production, and indeed 8K is indeed a reality and is being done. So as we've grown in quality, obviously we've grown in size, the amount of data that we have to handle, the type of systems we use have had to get faster, and generally creative people will be collaborating on high performance storage because that's really the only storage that they can do that on. So I wanted to talk today about disaster recovery. I think disaster recovery is something that is sometimes misunderstood. It's something that sort of ticks a box, and it only really rears its head, or you only really understand how bad your disaster recovery strategy is when the worst strikes and you are faced with business continuity issues and potentially huge amounts of money being lost. So I think we'd all agree that backup is essential, having another copy of your data somewhere else. But in most cases, bringing back the data from your backup storage can be a very painful experience, with large amounts of data needing to be moved at relatively low bandwidth, with quite painful extraction methods. Furthermore, it is fair to say that if you can't, you have your data on a backup where it could be the cloud, it could be tape, but bringing that data back onto something that people can work from is a totally different matter. Obviously, your primary high bandwidth operations won't work from cloud storage or tape archives such as LTO. So to have that high-speed collaborative area, you need to bring your data back from the backup onto something usable. Data these days is stored on storage servers, and generally shared storage comes in the form of SAN or NAS. Within storage servers, there are quite a number of different technologies that are put there to protect the data that's on them, to protect the unit in terms of it keeping running as long as possible, even after hardware failure. And I think probably a lot of us will be familiar with RAID levels, which is a way of combining your hard disks together and having various different types of resilience, with the benefit of them all working together to give you one big volume that's well protected. We also commonly would see dual power supplies in these units because obviously the power supply is a fairly likely component to fail within a server, and when that happens we need it to fail over to another power supply so that there is no interruption in service. The operating system disk, highly recommend to give that some RAID protection as well. And in a lot of systems, certainly IT-centric systems, you will find dual RAID controllers. But there is a warning sign over this in that you are giving your system very compromised performance because of the two RAID controllers working together. And actually, they will be bonded together by a software or hardware layer, which is a single point of failure. Alongside that, there is the potential for your motherboard inside a storage server to also fail. And of course, when that fails, any of the other fancy technologies inside the unit for protecting it will be negated, because literally that would be a showstopper. There are a number of different situations that a storage server, no matter how well protected it is, will be lost, or data will be lost. Certainly fire or flood, or force majeure. There's a number of different things that could happen to storage in a single location. In fact, in the past, you think you can predict all of these things ahead of time, but there was a large broadcaster in the UK who had a particularly large storage system and were very happy working away from this, thinking their data was very well protected, which of course it had dual RAID controllers, dual power supplies, all of the things that we would normally expect. However, the gas suppression system fitted to the server room, which was there to reduce the oxygen in the server room, was being serviced, and unfortunately an accident occurred which allowed one of the cylinders to bounce and go through a ceiling, whilst at the same time the incredibly well placed jets or nozzles for the gas system sprayed ice cold gas straight into the front of quite a few RAID chassis and instantly stopped all of the disks. I don't think anybody necessarily predicted this happening, and when it did happen, replacing the shared storage or the online storage was obviously one of the key factors, and that was done relatively quickly within the space of a week. But bringing back the data that was on their LTO library ended up being a 2-month and beyond process. So obviously a lot of people were very surprised at the interruption in what they were doing, also the fact that they couldn't access this data that they thought they had backed up, and again believed that they had a good disaster recovery strategy. So if we accept that RAID or storage servers are not infallible, then we would be looking at a number of different technologies, or certainly 2 technologies that come to mind. So clustered storage, I think probably people are familiar with. It's been around for a long time. It has advantages. It has some theoretical promises in terms of increased performance as you add nodes, and capacity, and obviously reliability from node resilience. Well, that's the theory anyway. The reality is that the nodes inside a cluster have to have a file system, and that file system sits across all the nodes. To give the best performance, or the performance that you would expect, this needs to be re-optimized on a very regular basis. When the re-optimization happens, the system performance drops massively. And this will happen when you lose a node, when you add a new node back in for repair. It will even happen with large deletions of data. It's not something that you would necessarily know from the marketing, but it's something that when you speak to people who own clusters, this is a very regular occurrence. The other problem, of course, with a cluster, not only is it expensive and complicated, it would have ongoing support costs to go with that. And the other problem is it's not a true DR solution. So a cluster is very well protected, but of course it sits in a single location. And when you put this to cluster manufacturers, they will tell you to buy another cluster, which obviously is going to be expensive and would mean in most cases that the two would sit at completely different IP addresses. Where they are sat at different IP addresses, the clients and servers on the network will have to obviously be redirected. And redirecting hundreds or potentially thousands of connections becomes extremely painful very quickly. Once you've redirected everybody to the backup IP address or the DR site, you then would have to redirect everything back again to the original cluster once everything is fixed and happy again. So a very potentially fraught with danger situation, inconvenience, and a lot of time wasted. So we will look at another alternative, which neatly brings me to Cloak DR. So Cloak DR is a single IP address dual system proposition. You can simply take two of our storage products and put them together with our software installed on both and a high-speed link between, and they will present themselves as a single IP address or a virtualized IP address. So everything on the network would be talking to one of the servers, and if there was anything to go on between the two servers, not only are they monitoring each other in terms of a heartbeat going between them and exchanging data, but they are also capable of instantly flipping that IP address between the two servers. And that takes around about a second to do. When the cloak, or if the cloak, was to experience a major event, an emergency failover would occur and the traffic would now be directed to the healthy server. Again, the IP address stays exactly the same. In fact, the path to all your files and folders stay the same. So everybody who is connected to a Cloak DR configuration could carry on working and probably wouldn't know any different, even if you'd gone along and stolen one of them. As I say, this fits extremely well into the DR that we've just been talking about, and this means that we can split our eggs into two baskets. The next situation, which is obviously slightly less scary, is removing one of the servers for routine maintenance, and that could come in the form of firmware upgrades. It could just be cleaning it out. Whatever you would like to do to one server, you can take one out and have everybody carry on happily working with the other server. So they'll interchange between each other and they'll do it quite happily. Obviously, when they come back, they will need to synchronize whatever data that they didn't have from being offline, but that is done automatically for you, so the whole thing is very seamless. One of the benefits of being IP or Ethernet connected in this case is that we can put them at fairly large distance away from each other. Current high-speed connections will easily work up to 10 kilometers, and providing you've got bandwidth and low latency, the two servers will be quite happy sat in different buildings. It could be two server rooms inside one building, it could be two separate buildings, but the main thing here is that obviously we don't have all our eggs in one basket, and if there was to be a fire, flood, imaging gas problem or similar, it wouldn't be an issue because we would work from the other server with no interruption in the performance that we are used to receiving. So I want to talk a little bit about how the technology works, and a couple of things that when you first look at it, you may assume this system is actually writing through data. So it is not writing to the primary server and then subsequently migrating to the secondary server. It is actually writing through, which basically means all data is perfectly in sync. And that is how, if we lose one of them within 1 second, the other one has taken over and it is doing the exact same job, delivering exactly the same performance. In terms of reading data, the Cloak is not just writing data to its partner idly. In fact, there are certain read modes that we have that will allow the secondary server to boost the performance of the primary server. This allows the system to deliver slightly better performance, but of course it means that the other server is actually doing something rather than just sitting there being written to until it's needed. Of course, when it is needed, it will switch and come online at full speed, and it's available for everybody to use with the same data on it. Up until now, we have been looking at slides of 2 Cloak boxes connected to one switch, but of course, to achieve the no single point of failure that is talked about a lot of the time, we would have to provide dual switches. In fact, if you use the multi-chassis link aggregation known as MLAG, you can have multiple switches with resilience and improvements in performance by directing packets through optimal routes. This is obviously something that is supported in very high grade switches, but it is the way to create the perfect circle. So your storage is resilient and your switches are resilient. Of course, in addition to this, we would need to make sure that the clients are dual pathed to both switches, and those switches are also dual pathed to the storage. But essentially, if this is deployed correctly, you end up with a true no single point of failure system. So you could go and remove a cable, you could go and remove a switch, you could go and remove a server, and the whole thing would stay up and people would carry on working. So I have a video which I will apologize now if it doesn't play back properly. If it doesn't, then not a problem, because we will be offering recordings of this session subsequently, which will have a video that does play back. I know that certain bandwidth issues do occur when we do this, but I'll give it a crack anyway. And this will give everybody an idea of what Cloak is like to deal with from the front end. And we will experience a failure, obviously on purpose, but a failure as in both cables from the power supplies will be whipped out, and we will have a system go down and see what kind of effect that has on somebody who's connected to it. So we will try to begin the video now, and hopefully it works.
For this demonstration of Cloak DR, we're going to be accessing the system via the Access Workspaces IP. Here we are looking at the web GUI, and we have the mounted share on the desktop. As part of this demonstration, we're going to be playing files back from the storage, also copying data to the storage, and then pulling the power out of the primary system, forcing a failover, to show what happens in catastrophic failure and power loss. So let's loop the video and get it continuously playing whilst we failover. The data we're going to be copying from the desktop is 65 gig of data, a folder called copy in, so let's place that onto the storage at the same time. When the power is pulled from the server, there will be no interruption to data copy and a minor pause in playback. So here the power is being pulled, the primary system is offline, the video then picks up playing again exactly where it left off and continues to be read, and the data is being copied onto the storage. This is exactly what you'd expect in a failover scenario. We're now working from the secondary system without the knowledge that has actually been switched in the background. One of the major drivers for Cloak DR is to ensure that this is transparent for both the users and also the machines connected to the system. Here the file is still copying and the videos are still playing back directly onto the system. So let's have a look at the web browser. It was previously pointed towards the primary system using the virtual IP, and the browser still thinks it is. However, if we refresh the browser, you'll then notice that this is then pushed to the secondary completely automatically, and this is exactly what's happened in the background with the mount. Logging into the browser, we can see the Cloak DR status page. It'll refresh and show up red, showing the error in progress, and also show us that the data is being directed to the secondary system. We'll speed up the copy a little bit here as well to get to the end of the copy. Video file still playing back, file finished copying, and we're complete. Meanwhile, on the Windows system also connected, we also have the data being copied onto the storage. The primary system is offline in the background and the data is still copying. As we speed through, you'll be able to see that actually the primary system has now come back online as our engineer has booted the server back up again. The Windows file copy is finished and completed, and we can then flick back to the Mac workstation and see what's going on. So let's flick back over to the Mac, and we can see that what's happening now is data synchronization. So don't forget, we've copied 65 gigabytes of data from the Mac, plus the data from the Windows that you saw there copied in. So now that the primary system is back online, as we've started it up again after the failure, we have to synchronize that data back. We have to ensure that data is in both places, and this is vitally important. Coming to the end of that copy now, it'll finish up and the heartbeat will go green to show this. Now that data is completely synced and our primary system is back online after a complete failure from power loss, we can have a look at the logs and then go back to the interface and see what the situation is. When we get to the interface, it'll actually tell us that this system was originally configured as a secondary, but is currently in a primary role. To reverse this, we need to go back to the direct IP, the management address of the primary system, go into the Cloak DR and reverse it. This will then turn the system back to its original configuration. And you'll notice in the background that video clip is still playing even when we reverse the vols back again. And now we have a complete failover, reversed, and Cloak DR has performed an incredible task in keeping the data safe and keeping people working.
I wanted to bring up a very nice setup that is one of our existing Cloak setups out there. This is for in fact, the #1 broadcaster in Philippines, GMA. They are a very forward-thinking broadcaster who produces a lot of their own content, and they edit and produce in 4K with very large work groups. At the moment, they have over 65 connected users, and they are looking to have more in the future. So what I like about this system is it is obviously extremely fast. It is our fastest platform. In fact, it's expanded out 3 ways, and then it is cloaked. In fact, it is also combined with MLAG deployed switches. So there is a true no single point of failure deployment, as all of these edit suites are also dual connected. And our system is producing an unbelievable 20 gigabytes per second, which was kind of handy because the minimum requirement that GMA had for this system was 15 gigabytes, which immediately early on sifted out the competition. I believe that we started at 7 storage companies trying to tender for the same opportunity, and this was quickly whittled down to 2 manufacturers. Now, GMA were very interested in high performance, but they absolutely did not want any downtime. And whilst these are post-production edit suites in the majority, they wanted no outage. So what they were looking for is a system that not only provided extremely high performance, but in the case of hardware failure or any kind of servicing they wanted to do, they didn't want a massive drop in performance, and they wanted very good protection. So this was a perfect opportunity because after all of the paperwork, etc., there was a POC, a proof of concept, where we were able to set up our system and the competitor system, which was a Dell EMC Isilon, and we had a number of real workstations connected to those systems and tested very thoroughly the healthy state, the degraded state, so where there's a node failure, and then obviously the repairing state that came after that. It was very clear early on, and certainly throughout the testing, that not only did the Isilon suffer in terms of performance with various different failures, it was also not capable of delivering this outstanding level of performance. The combination of disk and cache can be beneficial, but in the case of servicing this many edit suites with 4K, it absolutely had to be pure flash. Now, the problem that I see with Cloak DR is the immediate assumption is that it is designed for these kinds of systems and it would be very broadcast centric. And of course, it is ideal for these kind of deployments, but if we go back to the original discussion on disaster recovery, I believe that if anybody actually sits down and thinks about, what happens when there is a failure, how quickly can we get to our second set of data? Is that second set of data readily available or on something that we can collaborate and use? Is it possible to go days on end with people not working? Creative people are expensive, edit seats are expensive, and to have, days of outage or even weeks of outage or not be able to work with the same footage could potentially cost millions. And this is something that I think is very important here. Cloak DR is a piece of software that is developed obviously by GB Labs. It is for our platforms and it works on Echo 36, it works on Space, and it works on Space SSD. So it is true to say that you could get the lower cost units in the Space or Echo range and simply put them together with Cloak DR, and you would have a resilient system. This would not cost a huge amount and would certainly give everybody a good sleep at night, because should the worst happen, the other server will take over. And this has proved very popular with a variety of different industries, but obviously primarily broadcast would be a good target for this kind of technology. But again, I encourage people to really think about what true outage means to you and whether you can afford to be without your primary collaborative storage for any given amount of time. So we'll move on to the question and answer session. I'll just open up the questions and have a look. Okay, so we've got a question here about the type of connection that we have between the two Cloak systems, the primary and the secondary. So this needs to be a minimum of 40 gig Ethernet, and this is so that we have sufficient bandwidth for the Cloak and Pulse link, but also so that we have low latency to give the best overall system performance. So the GMA primary and secondary storage, the question here is, where were they located physically? They were located in two separate server rooms in the same building, but due to the size of the GMA campus, it is likely that they will be moving to two separate buildings, which is obviously preferable, but it doesn't really matter. They can temporarily sit next to each other and give that level of protection. But of course, to achieve the not having all your eggs in one basket situation, then you would want to physically separate. We've got a question here about how far can they be separated. Again, 10 kilometers would be quite extreme, but certainly 40 gig Ethernet is able to be delivered to that kind of distance with current technology and avoiding the use of any kind of repeater technology. This would obviously ensure the latency was as low as possible. Another question here about the 1 second pause and what it would have, what it would do to the connected users to the system. Well, in my experience, most systems don't really do very much more than stop the playhead. I think we were looking at Duncan's QuickTime video in the background, and it may have paused for a second or so, but really most applications will deal with this type of temporary pause very well. I've seen different operating systems and different versions of the same software handle things in different ways, but ultimately I think the worst that you would be facing is to quit the application and open it again, and of course you'd be dealing with exactly the same data. Got a very good question here. Can Cloak be added at a later date if it was a cost issue buying your storage in the first place? Well, this is actually a very good question, because Cloak or the systems need to be formatted for Cloak. So I guess if you knew that you were going to cloak your systems in the sort of near future, and you wanted to do it in 2 budget spends, then what we would do is create a cloak at GB Labs, and we would effectively ship half a cloak to you. The half a cloak would behave and act just the same really as a single storage, but of course when you are able to purchase the second unit, we can stick them together, they can talk happily, and from then on protect themselves very well. Just looking down. Okay, so one more question here is about CCTV and whether it would be suitable for that. I think so. I think this would be suitable for a lot of high availability applications. Certainly you're writing very critical data to the server or servers in this case. It isn't possibly as important to read from them immediately, but you never know. It could be that they want to get hold of certain important footage quickly, and obviously that would be completely up to date, and 1 second of switchover would give you the exact same set of data should the worst happen. So I don't see any other questions at this moment, and I think that I have covered most things inside the presentation. As I say, the one thing that I would encourage you all to think about going away from this webinar is what is true DR, and at what stage do you start employing more than just another copy of your data somewhere. Sorry, there is one more question that's just popped through. Can Cloak DR work with hyperspace? Unfortunately, it can't. The 2 technologies are quite different, and so far we have not found a way of combining the 2 in a stable, successful way. It is something that obviously we are open to doing, and we've put a lot of research into, but currently they do not work at the same time. So yeah, I think that's it. I must have used up enough of your time this afternoon, and if there is further information that you require, of course we have lots more detailed information. We have the video and the webinar recorded, and can supply a lot more detail on request. So thank you very much for joining me, and I hope that this has been useful to you. Obviously, we are quite happy to accept any questions you have afterwards or in the coming days, which leaves me to say goodbye and thank you very much for your time, and we will speak to you very soon, I hope. Cheers. Bye-bye.